Hello students, this is Professor Bharat Naik. Today we will be seeing continuity of model number 3 heat exchangers. Number of transfer unit. Number of transfer unit is directly proportional to the area of the heat exchanger. If we increase NTU up to 1.5, effectiveness increases rapidly. If we increase NTU more than 3, effectiveness increases but in a very slow manner. Therefore, NTU more than 3 effectiveness is high, but that will not justify the cost. Therefore, for the good design of heat exchanger, NTU is limited to 1.5. Fouling factor. Consider a pipe. Hot fluid is continuously flowing inside this pipe. Due to continuous usage of pipe, some extra material is deposited over the surface. This extra material is deposited over the surface because impurities are present in the fluid. This extra material is having low value of K and it will offer some extra resistance to the flow. The resistance offered by the extra material is called as fouling resistance. Fouling factor is equal to 1 upon U old minus 1 upon U new. Here U is overall heat transfer coefficient. Heat capacity rate. Heat capacity rate is the product of mass flow rate and specific heat, and it is defined as the amount of heat required to change the value of fluid by 1 Kelvin or 1 degree Celsius. SI unit is watt per Kelvin or watt per degree Celsius. Given for counterflow heat exchanger, the inlet temperature of the hot fluid is 80 degrees Celsius and outlet temperature of the hot fluid is 50 degrees Celsius. The inlet temperature of the cold fluid is 30 degrees Celsius and the outlet temperature of the cold fluid is 40 degrees Celsius. LMTD is determined as counterflow heat exchanger. In counterflow heat exchanger, both the fluids are flowing in opposite direction. The inlet temperature of the hot fluid is 80 degrees Celsius. The outlet temperature of the hot fluid is 50 degrees Celsius. The inlet temperature of the cold fluid is 30 degrees Celsius. The outlet temperature of the cold fluid is 40 degrees Celsius. Here, heat transfer takes place from hot fluid to the cold fluid. Therefore, temperature of the cold fluid will increases. The inlet temperature of the cold fluid is 30 degrees Celsius and the outlet temperature of the cold fluid is 40 degrees Celsius. We'll calculate T1 is equal to 80 minus 40 and T2 is equal to 50 minus 30 degrees Celsius. T1 is equal to 40 degrees Celsius and T2 is equal to 20 degrees Celsius. T1 is equal to 40 degrees Celsius and T2 is equal to 20 degrees Celsius. Therefore, LMTD is equal to 28.8539 degrees Celsius. Given for parallel flow heat exchanger, the inlet temperature of the hot fluid is 80 degrees Celsius. The outlet temperature of the hot fluid is 50 degrees Celsius. The inlet temperature of the cold fluid is 30 degrees Celsius and the outlet temperature of the cold fluid is 40 degrees Celsius. LMTD is determined as parallel flow heat exchanger. If both the fluids are flowing in the same direction, then it is called as parallel flow heat exchanger. Here, both the fluids are flowing in the same direction. The inlet temperature of the hot fluid is 80 degrees Celsius. The outlet temperature of the hot fluid is 50 degrees Celsius. The inlet temperature of the cold fluid is 30 degrees Celsius. The outlet temperature of the cold fluid is 40 degrees Celsius. There will be heat transfer take place from hot fluid to cold fluid. Therefore, temperature of the cold fluid will increases. Initial temperature of the cold fluid is 30 degrees Celsius and the final temperature of the cold fluid is 40 degrees Celsius. The initial temperature of the hot fluid is 80 degrees Celsius and the final temperature of the hot fluid is 50 degrees Celsius. We will calculate T1 is equal to 80 minus 30 degrees Celsius and T2 is equal to 50 degrees Celsius minus 40 degrees Celsius. T1 is equal to 80 minus 30, 50 degrees Celsius. T2 is equal to 50 minus 40, 10 degrees Celsius. LMTD is equal to T1 minus T2 divided by ln T1 by T2. Now, all the entities are known to us. Substituting all the entities in the above equation, it gives LMTD is equal to 24.85 degrees Celsius. Therefore, LMTD of counter flow heat exchanger is always greater than LMTD of parallel flow